Hey everyone, welcome back to DentChem. I'm going to make an important distinction today between substitution and elimination reactions. The most used, most popular reactions that you're going to see in university organic chemistry. Let's get straight into it. Substitution here, okay? What I plan to do, make a quick distinction between the both so we recognize that there are two sides to this. What I'll then do is include a video that goes more in depth on substitution, a video that goes more in depth on elimination, and then a final video that compares the two again. That way we can get a lot of practice in distinguishing and determining whether substitution or elimination is favored. There's going to be questions on standardized tests, and there will be questions on exams in your class this year. Let's get into substitution. Substitution, it's very well named. I'm going to substitute a leaving group for a nucleophile. So my starting compound here, I have a leaving group, okay? There's a DentChem video out there that talks about leaving groups, so if that's an unfamiliar term, I recommend you watch that and subscribe and like this video. I have a leaving group that's going to leave, and it's going to be substituted with a nucleophile. Big takeaway, substitution uses nucleophiles. Commonly used nucleophiles that are not bases are halogens, so chlorine, bromine, iodine, fluorine, as well as cyanide. Okay, those are going to be great nucleophiles and bad bases, which is great for substitution. What does SN1 and SN2 mean? Keep watching this short series in DentChem about substitution elimination and you'll find out. Elimination. Okay, so substitution we had nucleophiles. In elimination we use bases. I'm going to have a base. I'm going to have a leaving group here. Leaving group's going to leave, of course. Another well-named thing in organic chemistry, kind of rare. I'm going to have a base. Okay, bases, remember, are proton acceptors. And the biggest indication I've done an elimination reaction, I'm left with a double bond. We'll get more into this reaction when we talk about elimination purely. But if I see a base, I see the presence of maybe a double bond in my product, I've done an elimination reaction. Commonly used bases for elimination, a lot of nitrogen-containing compounds are strong bases. Terp-butoxide, common big bulky base. And another thing here, if we see the presence of heat in our system, that's a really good indication that we're going to do an elimination reaction. And even on a standardized test, if you see heat maybe on that reaction arrow, that's a dead giveaway that they want you to do an elimination reaction. So look for that in your product. And what should we be looking for on our product? Double bonds. I'll go into more detail on both of these individually and get some more practice. If you stick around, watch a couple more videos and get the most important reactions down in 10 to 20 minutes, okay? Give this video a like, subscribe please, and thank you for supporting DentChem.